Hello, today you see three quadratic equations listed here. They're all nicely in standard form, equaling 0. And the question is, are they worth solving? Because we know that a quadratic equation can have two solutions. Usually that's what we find. We have two solutions, but we've also found that there are some that have only one solution, and some other quadratic equations that actually have no real roots. They don't actually have any real solutions. Now, of course, remember that if we were to look at the graphs of the similar quadratic functions, and there they are listed there, then right away we could see how many x-intercepts the graphs had, and that would tell us right away how many solutions the function has, right? The x-intercepts of the graph are the roots or the solutions of the functions. If we're fortunate enough to have something like Desmos that can graph things really quickly, then we can just punch the quadratic function into Desmos and see how many x-intercepts there are. And here we see an example of a quadratic function that has, here's one that has two x-intercepts, therefore that quadratic equation must have two solutions. Here's a quadratic function that has one x-intercept, that quadratic equation must have one solution, and here's one just off to the side here that doesn't have any x-intercepts, so that one must be from a quadratic equation that has no solutions. And in fact, the three parabolas I have here are the three functions that are listed above, but which one is which? If I had to graph the quadratic functions associated with these equations without Desmos or some other graphing calculator, probably the first thing I'd do anyway would be to find the x-intercepts. And so I'd be right back where I started, because if I tried to find x-intercepts, all I'd be doing would be finding the solutions to these equations. Now, of course, the fastest way to solve a quadratic equation is by factoring, if it factors, and in fact I happen to know that two of these factor and one of these don't, and let's just say that I am not interested in seeing whether they factor or not. I can always try and solve them using the quadratic formula. So I'm just going to start and see if I can solve this thing by plugging in the correct a, b, and c values into the quadratic formula for each. And here's the first one filled out. Here's all the substitutions in the second one and in the third one. So I'm going to quickly work through these one by one. Here we go. X equals negative 12 plus and minus the square root of, well, 12 squared is 144 minus 16 times 9. 4 times 4 times 9 is 144 over 8. Looks like I get negative 12 plus and minus the square root of 0 over 8. So I guess I'm not going to be adding or subtracting anything. It's actually just going to be negative 12 over 8, which is negative 3 over 2. Looks like there is one solution to this problem. It is that x equals negative 3 over 2. In the second one, x equals negative 5 is positive 5, plus and minus, let's see, we've got 25, minus 12 times 6, which is minus 72 over 6. So 5 plus and minus the square root of negative, negative numbers in the square root, negative 47 over 6. Now I know that negative square roots, or negative numbers inside a square root anyway, there's no real such thing, so I say no real roots or no solutions. In the last one, just quickly working through, x equals positive 11 plus and minus the square root of 121 is negative 11 squared, minus 2, nope, plus a negative and a negative will give me a plus, so that's 24 times 10, 240 over negative 12, so x equals 11 plus and minus the square root of 361 over negative 12. I think my exact answers, or my exact solutions, are that it's going to be x plus root 361 over negative 12, and x equals 11 minus root 361 over negative 12. And if I punch those into my calculator, I find out that the square root of 361 is actually 19, so 11 plus 19 over negative 12, and 11 minus 19 over negative 12, so that's 30 over negative 12, which simplifies to 5 over 2, and 11 minus 19 over negative 12, that will simplify to positive 2 over 3. So it looks like this third one here gives me two solutions, two rational or two fraction solutions. So what's the point? Well, the point is this. I intentionally gave us three quadratic equations. One that had one solution, right? This one had one solution. One that had no solutions. This one had no solutions. And this one here had two solutions. So we all know that quadratic equations can have 2, 1, or 0 solutions. Is there a way to predict that without graphing it or going through the whole long process of trying to use the quadratic equation? Well, there is if we recognize where in our working here it became very apparent whether we were going to get solutions or not, and if we were, how many were we going to get? Now, I would say that that was decided by whatever happened inside the square root every time. Notice in this first one, when we worked out what was going on in the square root, we actually ended up with a square root of 0, which, because it got eventually eliminated, gave us only one solution. In the second one, we ended up with a square root that simplified down to a negative number inside the square root, which is not a thing, not a real thing. And so right away we knew, oh, that quadratic equation has no solutions, no real roots. In the third one, we got a positive square root, whether it worked out to a nice number or not. This one was actually a perfect square. That was nice, but because it was a positive number inside the square root, we ended up with two different solutions because we had to add it and subtract it to get our two solutions. If we look back at our quadratic formula, what was originally inside the square root? Well, it was this expression here, b squared minus 4ac. How many solutions a quadratic equation has is going to be determined by whether b squared minus 4ac works out to something that is positive, something that is 0, or something that is negative. If it turns out that b squared minus 4ac equals 0, that means that we are going to have one solution. If it turns out that b squared minus 4ac is less than 0, or turns out to be a negative number, then of course we end up in an impossible situation, and therefore there are 0 solutions. And of course, if we end up with a positive value for b squared minus 4ac, then we will have to add that root and subtract that root, and we will get two solutions. B squared minus 4ac has a name. It is called the discriminant. Discriminant means something that enables you to distinguish between two things. If you have discriminating tastes, for example, then you can tell whether something looks good or not. In math, the discriminant is just b squared minus 4ac, and it helps you to distinguish whether a quadratic equation has one solution, two solutions, or no solutions. So here's three examples. Three quadratic equations, and all we want to know at this point is how many solutions does each one have? Well, before we can do anything else, we of course have to get these in standard form. Everything on one side equal to 0, so we'll just quickly do some rearranging here. Minus 3x minus 4 equals 0. Looks like the middle one is already set up nicely, and that last one there must be 9x squared minus 6x plus 1 equals 0. And again, we could try solving by factoring, but we just want to know how many solutions there are. So, in the first one, we were going to pull out our discriminant, find out what b squared minus 4ac equals. Well, that equals negative 3 squared minus 4 times 2 times negative 4, and that's 9 plus 32 if I'm careful. And I don't even have to know what it is. It's going to be positive. It happens to be 41, so the discriminant, we usually use a capital D to talk about that, is greater than 0, therefore 2 solutions. In the middle one, let's figure out their discriminant again. B squared minus 4ac. Well, b squared is 5 squared, so that's 25, minus 4 times negative 3 times negative 6, right? If I look ahead, I'm already going to see, well, that's going to be 25 minus 12 times 6, so that's going to be minus 72. D is definitely going to be negative. Therefore, we will say for sure there are no solutions to that one. The final one, let's just check. We're checking for discriminant. B squared minus 4ac, negative 6 squared minus 4 times 9 times 1, 36 minus 36 equals 0. Well, it's not going to be 6. Equals 0. If the discriminant equals 0, then we have one solution. And now it just so happens that I have graphed 3 quadratic equations. I have graphed that y equals 2x squared minus 3x minus 4, right? Which is very close to this quadratic equation, and that thing has 1 and 2 x-intercept, just like the equation has 2 solutions. I also graphed y equals negative 3x squared plus 5x minus 6, which is the function that is very close to this one, and we said that that one had no solutions, and indeed this parabola doesn't get anywhere near the x-axis. There's no x-intercept for this function. There are no solutions for that equation. And finally, I also graphed y equals 9x squared minus 6x plus 1, right? Same quadratic function as this expression in the equation, and it has one x-intercept. We said there was one solution.